Okay, I will use this demo to a video to introduce my assignment and algorithm. So first of all, solution can, in our assignment, its successful rate is 100%. It's good, but it's not perfect. So I call it as a suboptimal solution. And I test over 10 times. And in my algorithm, I use two sensors. The first one is the front sensor. It scanned a negative 15 degree to up positive 15 degree, and another is left side sensor to scan the closest distance at the left side, and that distance is direction. And the logic, I will introduce my logic later. The first thing is the obstacle. And if there is an obstacle in front, which use the front LiDAR to scan the front side, the robot will turn right. And there will be a state storage variable to store the state of turning left, which is when the closest direction is greater than 90 degrees or 100 degrees, whatever, it will turn left. And this moment, the variable will be true. And if when the state is true and there is an obstacle, then the robot will turn left. So the logic is very simple. Another thing is if there is no obstacle in front, then there will be three lines. And the robot will follow in the keep line. So if the robot is on the left side of the keep line, it will turn a little bit right and back to the keep line. Otherwise, it will turn a little bit left. If the robot is over the boundary line, then the robot will go straight to find if there is a wall. And my codes include all of the necessary information that I have mentioned. The first one is the constructor. And I use constructor and the scan callback function to initialize all the scanning data. And I store all the data in the self.p, which is a list stored all the data, and a state variable. And then I write a function to find the closest distance and the closest direction of that distance. To be more precise, I use this for loop. It's more precise. And in the main function, the follow that wall, firstly, I set up some common variables, that is the velocity of linear and angular, and the distance of the three lines, and to find the obstacle detect if there is an obstacle. And this is the codes of if there is an obstacle, very simple. And this is the codes of if there are no obstacles. And the first circle is the robot is on the left side of the deadline, it will turn right. The second one is if the robot is between the deadline and keep line, it will also turn right. And if there is a special condition that if the left closest distance direction is greater than 90 degrees, which means the robot need to turn left, then the state machine, the state variable will be true. If the robot is on the between the keep line and the boundary line, the same thing. Otherwise, if the robot is over the boundary line, the robot will move straight. So this is the main function that will run the program. So I have tested over 10 times actually. And in the first 10 times, the successful rate is 100%. But only 60% of the tests are moving in the perfect route, which means there is no special conditions. And 40% are not perfect, but the program have some tolerant fault, so it has robustness. So in some fault conditions, it can tolerate them. So there is also an abandoned solution which I use for direction to scan, but the code is too complex and it's really hard to maintain. So I abandoned this solution. Thank you.